going to go through and finish this problem up here and bring this up just a little bit so we can see this one. Okay, so scenario one is the one with the circular beds, and they're trying to find the area of each of the circular beds. So right away, I know that this is going to be a little bit different of a graph, right? Because we're dealing with circular areas, and they use more rounded edges. So as your area increases, your radius will also increase, but it won't be a linear relationship because you're not using squares to cover this, right? So you have rounded edges. So your graph will also be rounded. So your graph is actually going to be graph A right there. Okay. So it's going to have those rounded edges. All right. Now the equation is going to be multiplicative because you're finding area. We always know it's multiplicative when you're finding area. But what I remember about finding the area of a circle is pi equals the radius times, area equals pi times the radius squared. So I'm looking at equation B, and I'm seeing y, or area, equals pi times x, which is really our radius squared. So there you go. There's the equation that you would use. Knowing some basic geometry about circles definitely helps us there. Now, scenario two is we're looking at perimeter, right? So we're adding, okay? We're adding dimensions together. We're using that broken yardstick at 6. So I'm looking for clues with that broken yardstick at 6 centimeters, right? So this group needs to determine the actual side lengths of the garden, all right? So 6 centimeters, it's not going to be a proportional relationship if it's additive necessarily, right? And also, so that means it's not going to go through the origin. And this looks like it could easily be like where 6 would start, and this would represent the broken part of the ruler because it starts at 6. So your graph for scenario 2 is going to be B. And your equation is going to be, it's not going to be a multiplicative relationship because you're just adding 6 to these dimensions because the yardstick is broken at 6. So it has to be y equals x plus 6. So that would be C. Okay. And now finally for scenario 3, we have this dimensions for a rectangular vegetable patch. We know for every 5 inches, we get 8 inches long for every 5 inches wide. So I can just quickly do some math. And if I do 5 or 8 and I divide it by 5 to find the ratio between the width and the length, I know that there's 1, 5, and 8. I'm going to use my long division here. Okay. I'm going to have to go into decimals now. 1 times 5 equals 5. Subtract it from the 8, I get 3. I can't take another 5 out of the 3. So I have to add a decimal place and bring it down to 0. How many 5s are there in 30? There's 6 5s in 30. 0 should go right there. I have 0 left over, and my answer is 1.6. So the ratio of width to length would be 1.6. So for every length, I have 1.6 times the width. So that's going to be my equation. And I know it's going to be a proportional relationship because it's multiplicative. If I put in a 0 and a 0, it's going to start at the origin, and it's going to be linear. So my graph is C. All right. Hopefully that helps, guys. Bring your questions to me at office hours or during our Zooms. Have a great day.